Okay, folks, 11.3, permutations and probability. And I told you just a second ago that we're going to talk about two words. Combinations you're very familiar with. Permutations, you've probably heard me say it, but you're not as familiar with it. Okay? A permutation is a combination where order matters. Okay? Let's say that we had 10 people in a race. Okay? And I wanted to know, before the race happened, how many different ways could we have a first, second, and third place? We got 10 people running. How many different ways can we have first, second, and third? Well, first of all, there are a lot of ways. I'll show you in a moment how we'll figure that out. But my question to you is this. Raise your hand. Does the order matter? Does the order of the three people who come in first, second, third, does order matter? Sarah Kay? It certainly does, right? Let's just say A, B, C. Let's say that that was first, second, and third, right? B, C, A, that's a different one, isn't it? B came in first. We could also have A, C, and B. That's a different one, right? We could have B, A, and C. We could have C, A, B, and C, B, A. Those are all different possibilities because order matters. That is permutations. Now let me ask you this. What if I took those same 10 people, all right, and I said, here's what I need. I need 3 people to be our representatives for the 6th grade. Raise your hand. Does order matter? Pace? No. No. A, B, and C is the same thing as C, B, and A, isn't it? Order doesn't matter if I'm just saying, hey, I need 3 people to volunteer to be representatives for the 6th grade. These two things count for the same, don't they? It doesn't matter which person raised their hand first. They're just 3 representatives. Okay? This is a combination. I'll show you that we're going to work with permutations today. Okay? So let's look at the writing that's up here, because I've spent a lot of time defining this stuff for us already. So a permutation, I'll underline it, is an arrangement or listing of objects in which order is important. For example, the 6 permutations of the letter A, B, and C are shown below. Hey, I already did that, didn't I? I didn't realize that that's what I was doing. But there you go. Now, this is something that we need to know. We see it a lot in probability. Permutations of n objects. That just stands for a number. Okay? We could say the permutations of 5 objects. Okay? The number of permutations of 5 objects is 5 times 5 minus 1 is what? 4 times 5 minus 2? 3 times, and then it goes on down, times 2 times 1. Do you see how that works? If I had 5 people in a race, not 10, but 5, how many different ways could they come in? I mean, how many different ways can I arrange those 5 people from top to bottom? Well, 5 times 4 times 3 times 2. Can anyone tell me what 5 times 4 times 3 times 2 is? What is that? Ian? 120. If I had 5 people running a race, they could come in 120 different orders. Everybody okay with that? Everybody understand that? This is the way we write it. We write 5 with an exclamation point behind it. This means, well, let me ask you this. What does 4 exclamation point mean? What does it mean? Can you tell me? Just tell me. You don't have to tell me what it equals, but tell me how I would find that out. Paris? 4 times 3 times 2 times 1. It's the number times every number behind it. Down to 1. All right? Now I'm going to have to stop here and start another video to finish.